Hey,
Hey, Kirk.
okay. Oh, there we go. All right, so it's working. You can hear me fine?
I can hear you fine. Yes. I just can't see you yet.
Oh, okay. Um,
There might be a button like down near the bottom to hit or something.
I'm looking, I don't see. Oh, here we go. Start video. Okay.
There you are.
All right.
That guy looks like
Okay.
he can bench 3 plates.
I think I can. I haven't tried it, but I think I can. Okay. So, do you want to just go over these 6 questions one by one?
Yeah, and some of them kind of lead into each other. So and then if I might want to ask like some other questions as we go, but yeah, is that okay? Do these look okay to
Yeah.
you?
Yeah.
Okay.
And is it does it make sense to maybe combine 4 or 5 and 6 together as we go?
Sure. Yes.
Okay.
Yes.
Okay. Okay.
Yeah.
Should I
So
start
yeah.
talking?
I'll start it off. Hey, so I want to thank Kirk Kandt for being willing to participate in this project. It's to show college students that there's good careers to be had in manufacturing, aerospace, operations, that kind of thing. And Kirk is an old friend of mine. We go back to Linwood High School, and when I was at UCLA, he was at UCI getting a degree in software engineering, I believe, or programming. And so the first question is, why did you decide on a career in aerospace/operations? How did that happen?
Um, I would probably say by accident. Um, when I was in school, I was always taking the college prep courses, and I always excelled in math and science. So I figured, that that's probably where I'd lie. But I really didn't know anything about any kind of careers. Neither of my parents finished high school, and they couldn't give much guidance about that kind of stuff. Actually, they pushed me into college. I was thinking that I'd probably just go in the military during Vietnam, right? So anyway, it was just by luck. So I wound up going to UCI, and what happened was, like I said, I've always been good in math and science. So I figured I was going to be in that field somehow. I went in as a math major, but I thought probably be a chemist because I loved chemistry in high school. And so the first quarter, I had a math class and a chemistry and a physics class, and I still needed a fourth class. And I didn't know what to take. Other people I knew were taking introductory computer science. I didn't know anything about computers at that time. I just thought you asked them questions and he gave you answers. That was just magic to me. Um, so I took the class, and the first assignment that we were given, I could not do. So I had decided that was my major, and because it was a challenge, and I needed a challenge. Um, so anyway, I went through the program, got my computer science degree, and really, I didn't interview for a job. I just kind of thought, well, someone would come get me. Really stupid, but that's what I was thinking. And somehow I did get a job. I'm not quite sure how that happened. Um, I went to work for a jet propulsion laboratory for about a year. I didn't like it, but that happened to be in aerospace. And it turned out that UC Irvine, when I was an undergraduate, I met a graduate student, and his name was Bruce Bullock, and he worked at Hughes Research Labs in Malibu. Um, After about 6 months that I was at JPL, he tried to bring me over to Hughes Research Labs. It took about 6 months to get me there. And I got in, and again, this was a research division. It was out in Malibu, but basically they got all the research dollars for all of Hughes aircraft, which had employed like 50 to 60,000 people at the time. So anyway, I just, aerospace just employs a lot of computer scientists and engineers and such. And it was just more or less random. I could have wound up going into a company that maybe made medical devices and needs software or whatever. It was just random. I never really had an interest in aerospace, actually, until much later in life. And a lot of people couldn't understand that. My boss at JPL, one time, said something like, well, why do you work at JPL? Because, everybody works at JPL is because, they like working on satellites, whatever. It's like, well, I don't care anything about planets or satellites or, space exploration. It's just, I'm interested in artificial intelligence and you happen to be, supporting that work. So that's the only reason. Later on, I developed, when I was about 50 or maybe a little bit later, I started developing an interest in space exploration, but that came much later in life. So,
that's interesting. I wanted you to, if you don't mind, tell a little more detail about when you were in 6th grade and you were getting bored to death by math class. I know this is backing up a little bit, but
well, sure. Well,
yeah.
What happened with me in elementary school, I was very good at math and science, less so in English, but, all the way through elementary school, they'd give an assignment in class and, maybe it was supposed to take you an hour and it took me 5 minutes. And then I'd throw spitballs, at all the other kids, right? I mean, that's what you did in elementary school. And the teachers didn't like that. And I got lucky in 5th grade. There was one really good teacher, and he kind of helped me out with some math, gave me some special workbooks that were more advanced than what the other kids were getting and things like that. But then in 6th grade, I had a teacher that gave me his college calculus book. And then he started teaching me calculus and started giving me assignments, homework assignments in that, book. And so anyway,
So if things were a little different and people in the programs were set up, you could have been one of those guys that was graduating from high school when you were like 12 years old, probably, huh?
Well, I don't know about that. I'm sure I could have taken all the K through 12 classes in math and science probably by the time I was, easily out of, 6th grade. But I struggled with English. English was very hard for me. And I think I told you that, when I went to take my SATs, you get 800 as a perfect score. I think I got 780, but I was 99 percentile. But on my English, I think I got a 400 or something really bad, and it was like 35 percentile. So English was something I struggled with. I never did well. I certainly couldn't have taken. I don't think 12th grade English and have achieved, done well enough in that in 6th grade. But in the math and science courses, yeah, that would have been no problem at all. Matter of fact, when we were in high school, I was the only sophomore taking chemistry, and I was the only junior taking physics. Everybody else took their junior and senior years, and I took to my sophomore and junior years, and then I went to a JC to take calculus and physics and chemistry. So, but yeah, if we had some kind of AP courses, I could have whipped through all those in the math and sciences very rapidly.
Yeah, and just another little background thing. I remember when we were kids and we were friends. You and I were friends, and we were friends with Bruce Burdick. And so the rating system was after the testing, 7th and 8th grade, you were a 7-1 or 7- 3, and eighth
Yeah,
grade was, yeah.
yeah, you were 7, 2s, 4s, and all that in seventh grade. So 7, 2 was, the smart kids, and 8 1s and 8 3s and 8 5s were the smart kids. And I don't know. I don't think there was probably a lot of difference, if any, between the 8 1s, 8 3s, or 8 5s and things like that. I can remember that one time, uh, I guess it was in eighth grade, they took all the 8 1s and 8 3s and 8 5s, and they took us all to Devil's Punch Bowl on a weekend for a field trip, which was
That's,
pretty cool because all
yeah,
I knew was kids in the 8 1s and 8 3s. I didn't know anybody in the 8 5s. Um,
yeah.
anyway,
Well, you and Bruce were like in the top groups, and I was a little behind, and I was always pushing to catch up with you.
whatever. I don't know.
Yeah, yeah.
To be successful in life, I don't think it's, well, just about academics. And I'll give you an example. I mean, I won't name the name, but I had mentioned, no, I actually did not mention. Anyway, when I was living in Linwood, I lived in an apartment building, and the kid underneath me was 1 year behind me. And he was salutatorian, which meant he graduated number 2 in his class, right?
Yes,
And it turned out he went to UC Irvine. So of course we're going to school the same year at UC Irvine because I stayed out of school for 1 year, right?
yes.
He flunked out his freshman year.
Oh, wow.
Um, he couldn't make it. So in high school, he studied really hard and did really well in high school. But when it came to college, it was too difficult for him. He also discovered girls and alcohol, which probably didn't help. But being successful in life isn't just a matter of being smart. It's a matter of working hard
Yes.
and pursuing a career that you have natural talent in. If I had tried being a novelist, I'd be horrible. Um, Now I improved my writing and speaking skills, speaking skills through my undergraduate school and graduate career, and then even once I got in the work environment, I continually got better and better and better. But
Yes.
I could never be a novelist. It's just something I couldn't do. So no matter how hard I worked at it, I could never be a musician. Had no musical talent whatsoever. Um, so it's picking the right career that matches your skills. As a human being.
Yeah, it sounds like you knew what you were good at. You were good at math and science, and you stuck with that and pursued that, and it turned out to be a good choice.
Yeah, it was. I mean, and I enjoyed it. You know, I mean, I was really good in baseball. Would have loved to have been a professional baseball player, but I think it was fairly obvious that wasn't going to happen. And later on in life, I raced motorcycles, and I was really good at that. But the difference between being you know second tier or third tier or fourth tier and first tier is significant. So I could be the best guy in Southern California, but I was nothing at a national level, you know or
Yeah,
international, so you couldn't make a living at it.
right.
And I know a lot of people that were fantastic musicians and fantastic artists. You look at the work they do, and it's like amazing, but it wasn't good enough. So I happen to be in a field where uh I was good at something that was marketable, and it worked out for me.
Yeah. So you went from you were at JPL, and then you went over to Hughes Research. Can you talk about any of the projects that you worked on over there and some of the highlights?
Well, Hughes Research Labs, the projects I worked on, the first laser ever built was at Hughes Research Labs. So they're basically a whole bunch of physicists, a lot of them from Caltech. Um, and we were this little small software group that specialized in artificial intelligence. And with that, we actually specialized in computer vision. Um, and when I came aboard, we were trying to do what you would consider to be knowledge-based computer vision. So you're trying to build models of the environments and use artificial intelligence that understood those models and then use them to recognize, what you see. Okay. So a lot of that technology. Okay. So what we did was basic research. So we came up with a lot of good algorithms for computer vision. We came up with a lot of good algorithms for uh, dealing with different kinds of environments. So if you have your sensors, some of them could recognize, if you had an IR sensor that was that good at one thing, if you had one, it was just, a natural sensor, you would have to use a different set of algorithms. If you were in different environments, clouds versus sun, you'd have to have different, algorithms. So you had all these algorithms that people developed, including us, and you had to understand uh, that when you had them on a system, whether they worked or not, and be able to switch between modes, okay, detect when you started not performing well and then start performing well. So that's the kind of things that we did. So it's all basic research. We published a lot of material, uh, but we never built anything in the sense that we had a real product. But the thing of it was all of our technology wound up going principally to Hughes Fullerton and wound up in cruise missiles.
Oh, really?
So all the cruise missile technology that was built by Hughes Aircraft Company was done at Hughes Fullerton. So all this stuff we developed wound up on special purpose processors in the nose cone of a cruise missile.
Cruise missile.
Um, yeah, but later on, that same group uh, wound up building this first vehicle that could actually travel on a road, and it did it about 5 to 10 miles per hour. And that was done in about the mid to late 80s. And I was at Hughes Research Labs from the late 70s to the early 80s. But that same group of people and all that technology wound up with, you know, um, self-driving vehicles that could drive at 5 miles per hour versus 50, you know.
Yeah.
Um,
Well, so that was cutting edge, but that was the same kind of technology that ended up on the Teslas and other vehicles, right?
yeah, I would assume, I mean, I'm out of that field now, but they have much better sensors, they have much better processors, and I would expect they have much better algorithms, like with anything. But I think the primary difference is they got these LiDAR, I think it's called sensors. I don't, some kind of laser thing, don't know
Yeah.
anything about it. Uh, but I think the big breakthrough is having those LiDAR sensors. And of course, uh, the computing power in this iPhone that I'm talking to you with right now is probably orders of magnitude more powerful than the computers that we were using at that time. We were using PDP-10 computers which had 1 MIPS processing. This iPhone probably has 50 or 100 MIPS processing power. I'm just guessing. I really don't know. My desktop is infinitely faster than, the computers we were using back in, the late 70s, early 80s.
Right. Right.
And that same group wound up, uh, like I said, we went out and did this self-driving car. And that was one of the 3 principal programs within DARPA's strategic computing program. But in the early 80s, before I left, um, me and Bruce, we were at an AI conference in Pittsburgh, and we met a guy there uh, that happened to work for the CIA's Office of Research and Development. So we told him, what we were doing, and he had an interest in that, and he said, "Well, why don't you write me a white paper?" And it's like, "Oh, sure, we'll do that. Okay, no problem." Uh, And it's like, "Well, how big should this be? Are you talking like 100, 200 pages?" And he goes, "No, just like, 5 pages, like statement of work, what cost and whatever." It's like, well, okay. So most of our money, half of our funding came from internal research and development funds from Hughes. We basically got like 90% of the money for IR&D in Hughes came to the Hughes research labs. And then the other half we had to get from outside. And almost all of that came from DARPA and the Air Force Office of Scientific Research. So we met the CIA guy, on the intelligence research organization, and told him what we wanted to do. Now, normally when we write a program or a proposal, we get awarded a contract and the money shows up a year or two later. I mean, there's a long lead time, right?
Yeah.
So we wrote them this white paper, and we didn't expect to hear from them for like another year. And the guy from contracts came in a couple weeks later and said, "Your money showed up." It's like, what? Yeah, your money showed up. What money? Well, from this, the CIA Office of Research and Development. So we got like $1 million, which was a big chunk of change back in those days for doing research.
Yeah.
And it's like, well, damn, we like these people. So as it turns out, uh, that organization wound up getting a lot of money from the CIA to do basic research on computer vision, which I would imagine wound up in spy satellites at a later time. But the thing of it is after a while, all those programs went black. All the people got the top secret clearances and decided classified. And, I was out of that loop at that time. I never had a top secret clearance. But the thing of it is all that work led up to having a lot of impact in cruise missiles, in intelligence analysis, in spy satellites, basically automatically recognizing what's going on the ground. You didn't need human analysts; it would be all automated.
Right.
And like I said, those guys did the initial work on the robotic vehicles.
Well, that's amazing. So some of the stuff that you see where, like say there's a conflict in the Middle East and Israel is hitting a target and you see these videos that pop up, some of your technology is probably on some of those weapon systems, I would think.
Yeah, some of the earlier stuff, I would assume that a lot of it was more on the analysis side of intelligence. I would assume that a lot of it is on uh, uh, recognizing objects in imagery that was gathered from spy satellites
Mm-hmm.
and aiding intelligence analysts in doing their job. I think very little of outside of the cruise missiles. I don't think any of it probably wound up in weapon systems at all.
Oh, okay. Okay. Yeah.
Now later on, when I was at Xerox, I wound up working for a facility that did all classified information. Of course, I didn't have a clearance, so I didn't do any of that. But we had this one project again with the CIA, and what happened, it was the motivation for it was after the hostage crisis in Iran. People were wondering, well, how did things get so messed up? Why were we wrong that the students weren't a problem? Okay. So it turns out a law professor at Rice University named Dave Shum took a 2-year sabbatical at the CIA's Office of Research and Development. And he had an idea of being able to have a system that would help intelligence analysts make good, do good analyses. Okay.
Right.
So we wrote a response to that proposal at Xerox, which we won. And the idea behind this is, when an intelligence analyst is given a question by a president or somebody else, that says, are the students a problem in Iran? Then they look at it from economic perspectives, from uh, political perspectives, a social perspective, and there's probably one or two other things that they address. All these things that it could affect. an outcome. So the idea was that when given a problem, that you needed a solution for, to make sure someone did a thorough analysis to be able to look at a problem, break it up into a whole bunch of solved problems, associate evidence with that, all those sub problems, to be able to look at the source of all that information and argue about the veracity of that information. So basically, you could create this whole argument, okay, about some issue, and you could look at those arguments and all the sub-arguments all the way down to the lowest level and look at all the evidence that would support any of those arguments, and to be able to argue about the rationality of those, and then produce a good report that represented a good analysis. Okay, and then once you did that, and someone said, "Hey, this was the great analysis," then to be able to extract the domain independent information and use that to create other analysis in similar problems. Okay, therefore
Sounds good.
elevating the quality of all analyses done by everybody. And that, once you had something like that, then you could go and look at analysis and say, well, you don't have this information that supports this, and you would be able to see where the holes or gaps are in the analysis. So I worked on that for a couple of years. I worked at JPL on 3 different times. The first one was on the Voyager project, and I just wrote, system code that allowed commands to get uploaded to the spacecraft. When I went back there a second time, I was there for 4 years, and I worked on, again, artificial intelligence research, and it was all having to do with planning and scheduling. So if you look at JPL missions, you have all these scientists that want to do their science, and they're oversubscribed resources. You can't do it all, but each science activity has some sort of value. Okay, and you have all these resources. You got resources, you got people resources associated with ground equipment. We have 3 major facilities that track all the satellites. You have to point them in different directions. You have to work at different frequencies. You do all these kinds of things. So it's this huge scheduling problem. So you have to schedule all the ground resources, the physical assets. You have to schedule all the people on the ground. You have to schedule what can be done on all the spacecraft to solve all these science missions. Okay, so you have this big problem where you're trying to get the maximum science on oversubscribed resources, and it's a matter of how do you plan the scheduling all those resources so you get the best value. So that was essentially everything that I did at JPL for those 4 years. And there were several programs that I worked on while I was doing that. Now, the first 20 years or so of my life was in artificial intelligence, but then I went off and started working on, what you would say is normal kind of software. It wasn't AI, it's just, system software, I guess you say. And so I spent several years working on MER, which was the second rover that we actually put the 2 rovers up on Mars. So I worked on the flight software of those 2 systems. And then those were, I forgot what they were even named now, but we had 2 rovers that were, like the size of a desktop. Odyssey, I think, was one, and I can't remember the other one. Oh, Spirit and Odyssey. And then after that, I worked on Mars Science Lab, also on the flight software team. And that's the rover that's still roving on the ground. That's the one that's like the size of a Mini Cooper. So I worked on that. So I worked on the flight software team on that. What else? I worked on a couple other missions, but those were the 2 big ones. And then later off, I went into quality assurance for about, I don't know, about 5 or 6 years. And then I went back and started working ground systems, but not writing any software at all. When I started working ground systems, I worked for the chief engineer, and basically my role was to define policies and procedures for the whole organization, which was maybe 300 people, and then just monitor that those policies and procedures were done, and to ensure that they had the positive effect on quality that we expected, you know. So you just don't, put the policies and procedures in place. You measure and measure, you make sure they had the effect that you expected. Um, so that's a brief. That's I mean, actually that probably represents about half my career.
Yeah, I was thinking that if you have time and you're willing to do it, we might want to do another video, uh, maybe next week or something, if that would be suitable to you.
Yeah, that's no problem.
Okay. Um, so I wanna ask you, you had an amazing journey because your parents didn't graduate high school, but you were a bright person. You had uh, whatever you want to call it, God-given skills and abilities or aptitude, and you applied yourself and you did well. So can you elaborate on that a little bit? Like what was that like? I mean, as a kid, were you driven by something? Were you driven through your career by something? Was there a guiding light or a mentor, or what was it that drove you?
Well, I never had a mentor. That's one of the things I wish I had. Um, it's one of the things I would advise someone to do is, once they go out working, make sure you know, they pursue something that they enjoy. And then once they're in there, you go and look at people and, you know, try to identify someone that you want to be like, that either as a person or as a scientist, their technical achievements, or in terms of their career. Some people are just scientists or engineers like me. You know, I never had an interest in moving up the management hierarchy. But if you're interested in moving up the management hierarchy, look at the people that have been successful in that and try to figure out what it is that they do or the characteristics that they have as a person that made them successful in that. And then you mimic them, you know.
Well,
Um,
and you didn't get into management, or you didn't have an interest in it, but you still had a highly successful career.
oh yeah, yeah.
Yeah,
I mean, you, at JPL they have a management line, well, a management career path and a technical career path.
right. Right.
And the primary difference is if you go up the technical path, as you go up higher and higher and higher, basically, you know, I've, I'm trying to say not intelligent, but basically, as you go higher up, you either have to be more intelligent or you had to do more and greater technical things. You're the one that can always solve problems and do things that other people can't. Okay.
Right.
And if you go up the management chain, I don't know. I guess that's probably someone that is better able of putting people together that can achieve some goal. But you have two chains going up. And the thing of it is if you go up the technical path, you sort of have control of technology, problems and solutions.
Mhm.
And if you go up the management staff, you have control over people and money. So in that respect, you have power. Up the technical chain, you don't really have power, but your knowledge has influence over the technical decisions and solutions that actually get done. The people on the management side don't design the satellites or the rovers on Mars or any of that kind of stuff, right?
Yes.
But they are the ones that make the funding decisions, the personnel assignments and all that kind of thing, that actually make the stuff come together. And, you know, at some point in your life, you have to figure out which one you want to be. I
Right.
was never interested in controlling people or money. I was always interested in controlling solutions, figuring out how to get things done and make sure that they got done the right way.
Yeah, and the other point I wanted to make, and Boeing was the same way, but I wanted to make a point, and you could elaborate on it if you want, but that both roads are well compensated. I mean, you can go with the career in leadership and get well paid, and if you go with the technology road, and those people are well compensated as well, as long as you're doing a good job. And
oh yeah,
yeah,
that's true. But the one thing that's kind of frustrating going up the technical side is it's your responsibility to convince the managers that have the power to do the right things. And sometimes they don't have that ability. Now, like at JPL, there's around 5,500 people, of which 3,500 people are, let's say, engineers. Okay, so they're aerospace engineers, computer engineers, that are designing hardware, software engineers. So out of those 3,500 people, there's about 1,500 software engineers. So, software engineers are almost half the people that work on the technical side. But all the program managers have their degrees in aerospace engineering. If it's a science project, it might be a physicist. But basically on the engineering side, it's like aerospace engineers trump electrical engineers and mechanical engineers, which trump software engineers. So on software engineers, if you go on a flight project, software's not even talked about until like the 5th level, even though the software basically controls everything. And if you trace all of the JPL's failures, like 90% of them go back to software. So the problem that we had on the software side is now you need more money or more people or more equipment, whatever it happens to be. You have to go and convince like an aerospace engineer, okay, why we need that money or personnel, whatever it happens to be, to solve your problem. And they have much greater difficulty understanding that than if an electrical engineer or an aerospace engineer goes and asks that aerospace engineer or electrical engineer that I need more money for X. They tend to get their money much easier. And so, there's problems. I mean, one of the things I think I had mentioned earlier on is if you're a software engineer, you should work for a company that's primary product is software, so an Apple, a Microsoft, something like that. If you're an electrical engineer, you should be working for a company that makes devices, whether that's computers for, NVIDIA, or if it's a medical equipment device maker, and makes some kind of pacemakers or whatever. And if you get a degree in aerospace engineering, you should be working for a JPL or a Lockheed or whatever.
right.
But the software people that I know that have worked in aerospace companies that are making the hardware, they tend to have some problems.
Yeah.
I think more so than the engineer, electrical engineers and such.
Right.
So that's something that someone should always be aware of.
Yes. I was going to say that we're going to time out here pretty shortly.
Okay.
So I will say that Kirk will, between now and next week, I'll set up another time, and maybe we could try that other platform, the one you were suggesting. Was it Google Meetings or something like that?
It's called Google Meet.
Google Meet. Okay.
And, yeah. So if you just Google